Welcome. My name is Bob Tickelman. I'm a Microsoft Principal Technical Trainer, and I'm excited to be your guide for learning path number 5, Implement Containerized Solutions as part of the AZ-204 course. We're going to take a look at 3 different modules or 3 recordings where we're going to take a look at managing container images in the Azure Container Registry. Now, this is going to start off with a broader conversation to talk about what are containers to begin with, why do I need them, and then how do I create them and where do I put them. We will then expand it into a variety of different Azure services that can be used to deploy containers. We're going to take a look at container instances and container apps. I'm going to add in the full range of containers into this discussion. We're going to take a look at Azure Containers as part of App Service Plans, and we'll also take a look at the full-blown Azure Kubernetes Services, or AKS. So I'm going to go above that, but throughout these series, we're going to break it up into those 3 pieces. Module number 1, which is managing container images in the Azure Container Registry, is going to talk about your ability to create your own container registry and the images within it to meet your specific requirements. So before I get into this module, where we're going to take a look at the benefits of an Azure Container Registry, we need to understand what a container is and why I even need a container registry. We're going to compare and contrast it to the Azure Container Registry versus other ones that are out there, things like Docker and public repositories that you can use. And then we'll take a look at how a container is used and deployed using a Docker deployment file. So before we get into this, let's take a look at the use case of what a container is, why I need it, and why I need a registry of them. To start this whole discussion off, we have to go in the Wayback Machine and take a look at the traditional way in which applications were developed and deployed. So starting back in other recordings, you've heard me refer to the monolithic application deployment. And this was the traditional way in which we designed our applications. And I keep going back to a product like Microsoft Exchange that took 30 gigabytes to install. It took up to 16 cores that you needed to run it. It needed 128 gigs of RAM. And so all applications at the end of the day, no matter how they're built, how they're designed, they need some core resources. And this is where you're taking a look at the compute, memory, storage, and network. Whether this be the traditional on-premises environment where you built an operating system to run, and it would then take up some of those resources. So I have some hardware. In this case, it's got 48 cores, 512 gigs of RAM, and 8 terabytes worth of storage. Now, just to deploy the Windows operating system, there's some overhead. So in this case, I need 4 cores as a minimum, 8 gigabytes of RAM, and I needed 30 gigabytes to install the Windows operating system. So that gets removed from the overall resources that are going to be made available to your application. Now, I then take my application. In this case, it might be Exchange, and it needs all those extra resources. As I said, it needs 16 cores. It needed 128 gigs of RAM, and it needed another 30 gigabytes to run or install the application. So you're seeing an example of how that might work, and that was great. Now, I have more resources than I actually have needed for the core operating system and this application. So what might happen is you might deploy more than one application to optimize your use of the resources in this environment. I'm going back to more of that traditional environment. Now, this also would be the case in the IaaS world, or the infrastructure as a service, running virtual machines in the web or even virtual machines on premises. Now, this introduced a whole bunch of potential issues. Now, if you had a misbehaved application, in this case, let's say app number 2 became hung for whatever reason, and to do that, it needed a reboot of the operating system. Well, now the misbehaved application negatively impacted application number 1 that had, for no fault of its own, had to go through a reboot cycle. So there's just a kind of a Wayback Machine, how things used to work. Well, this changed over time as we added more applications and had more complexity to optimize the use of our hardware. And so what we started to do then was we looked at virtualization, going back to the on-premises world using Microsoft's product of Hyper-V, or maybe using something like VMware, or going to the IaaS, or infrastructure as a service model. We started to work with virtualization. Now, I still needed a base operating system, but now what happens is we started to deploy virtual machines that had their own operating system. So out of my 48 cores, I needed 4 for the operating system, plus I needed to have a hypervisor. And in there, I've got a Windows operating system that has 4 cores with its need for 8 gigs of RAM. And then I would run my application on top of this. Now, this provided the capability of me to be able to separate my applications. So this way, if application 2 became misbehaved, I then only had to reboot that operating system. But you'll see that the overhead of 4, 8, 12, and 16 cores are taken away to handle this infrastructure we're dealing with. So Hyper-V, or the hypervisor capability, provided some great features for us, but we still had to maintain multiple operating systems and the overhead that went away along with this. It also allowed us to potentially run other versions of operating systems. Even when we moved to this new method of being able to deploy applications in a microservice model, so now I have that green application, it's now broken into a group of microservices that all run on that infrastructure. And so now I can stop and start individual portions of an application, but that could still work in a microservice model, but still I had a base operating system for us to work with. I could do this through VMs if I wanted as well, to manage and partition these off depending on my resource utilization, but still there was some overhead. Now, at about the same time, this is when we started to get into containerization, especially in the microservice model. The microservice model really drove containerization, which now didn't require a hypervisor. It needed some container product to provide the ability to now have not just your application run in a small container, but it also provided transportability. There was a point in time where if you had an application, you would have to write multiple instances of that application, one to run on a Mac, one to run on Linux, one to run on Windows, and you would have to maintain multiple sets of code for each of those environments. Containerization allowed one instance of that application that ran on that container product to be the same application that ran on a container on Windows, a container on Linux, a container on a Mac. It would be the same application because the container product provided the obfuscation of the underlying operating system. They spun up very, very quickly because they were actually protected resource utilization of the underlying operating system, making them available in a protected way to that application. And this is where containers started. Now, there's a whole variety of companies that were competing in the container product, of which you probably heard one called Docker. Docker was the predominant one in the industry and took over the early days of the container model. We're going to get more details into what a container is. Now, a container is where you run your code. And you'll see this come up in more diagrams in just a few minutes. But then there's the thing called orchestration. Orchestration is the art or the process of managing one or more containers. As a standalone container running your application, how do I scale it? How do I get more instances of the application? How do I have containers talk to each other? All of those management pieces took place through products called orchestration, of which Docker had one called Swarm. Now, Docker Swarm was the tool that Docker tried to have you use to manage their containers. They were predominantly the container product. They wanted everybody to use Swarm. But what happened is, initially developed by Google, we now had Kubernetes. Kubernetes are an orchestration product, not only for Docker containers, but literally every single version of container out there. So it became a single pane of glass to manage, regardless of the container environment that you're working with, an ability to manage all of the containers that you're working with. Now, from its initial inception, it's now been taken over by a consortium of open source environments, of which Microsoft is part of, that contributes to the ongoing development of Kubernetes. And so I want to make sure that we're very clear about the distinction between a container a container run application, and the orchestration or management of the container environment. So now what we want to take a look at this orchestration and what a container is. So looking at the components that we have, a repo or repository, whether it's in Azure, GitHub, or any of the other locations that they could exist, is where your application code exists. This is often called a code repository, a change control system, but that code equals your application that you need to deploy. A container registry is a registry or a location of a variety of base images. If you're familiar with the old virtualization world where we used to talk about gold images, they were template versions of operating system that maybe had just a plain vanilla operating system, or maybe one that had some tools installed with it that you could deploy as a base image, spin it up, and then run your applications off of, a new instance of a virtual machine based on that base image. And that's basically a container registry. Now I've got two shapes here that are identical. One is just slightly larger than the other because maybe the amount of information or the size of resources that it can work with are different between the two instances of that container. Now they're basically the same configuration. You'll see that I've got a green outlined object here that is another container image, but this one maybe started off as just a plain vanilla, but maybe I added some tooling to it. Maybe I add some development tools or WinZip. So it fundamentally changes what that container was. It's not just a bigger instance of another container, it's a completely different container. Now I'm going to show you where there's a public container in just a second here. Let me go off there. And you can see an example of what it is I'm talking about. So what you're seeing here is from the Docker location in their container registry, they have a little over, I think in total, there's something like 8,000 different container images that we could pull from their registry. So this is an Nginx model. It talks about, we've got, a number of pulls. We've got BusyBox. We've got one with Redis cache. We've got Postgres, which is a type of database. I've got one with Python installed in it. I've got Node in this one. I've got an Ubuntu base image. I've got one with MySQL. So these are repositories of images that you could go to, and if you trust the source, you could download your image repository from here to deploy your application in. Now, when you take this build process, which is a document based on a language called YAML, it is going to identify a location to grab some code from. It's going to grab a container from a container registry, and then it's going to deploy that to a thing called a pod. Now, a pod is a unit of compute. In this case, this green object with some code deployed into it becomes an instance of your application using the resources allocated to the pod. Now, let's say that this pod has been allocated 2 cores and 4 gigs of RAM. All of those resources are going to be made available to it. Now, what happens is that pod runs on a virtual machine or physical machine someplace running the container product for that container that you've deployed. It's then going to carve off a special set of those 2 cores and 4 gigs from that base operating system and any other tools that are deployed to that base operating system and make them available to the pod, therefore making them available to the container inside of that pod. Now, the vast majority of pods have a one-to-one relationship with the container. Much like the app service plans, you're seeing a very similar, if you've seen that recording where we talked about an app service plan was a configuration of resources in an Azure region and a set of features, things like scaling that you had. And you could deploy one or more applications, app services, inside of the app service plan that then could share the resources that were allocated at the app service plan. That same construct is now working, but now within the container environment that is, taking on a very prevalent position within the industry. Now, if I were to add another shape here of another container that has its own code, so it is a different app, so code number 2, these two containers would share access to the common resources in the pod that they work. Very similar as they would work inside of the app service plan, you're seeing the same idea here. Now, the vast majority, as I said, the number of pods have the same number, have a one-to-one relationship with the containers that live inside of them. Now, a pod exists in the construct of a thing called a node. And a node, for all intents and purposes, is a virtual machine. So this VM might have 24 cores. It might have 128 gigs of RAM. And it may have several terabytes worth of storage. So I could have multiple pods, each with containers in them. This one has 2 cores and 4 gigs of RAM. This one might have 8 cores and 24 gigs of RAM. So I've got a total of 10 cores out of the overall cores. So I can put enough pods on here until I consume all of the resources of the node. And when I consume all the resources of the node, I need to create another node in a similar configuration. And this is referred to as a pool. All of these constructs that I've just talked about, a pool, a node, the management of the resources of pods, is all part of the Kubernetes portion, or the orchestration of the environment. And how does this application maybe talk to another application in another pod? Well, if they're on the same virtual machine, that is going to be done from within the memory of that virtual machine, and it's going to be done as a local call. But if it needs to go out through the network card of the VM and talks to another VM that has a network card, maybe they're on the 10 network, 10.0.1. some number, and we got 10.1.0.1. another number, somebody needs to control what is the port number on this IP address talking to what port number on another VM. All of that is part of the orchestration. So as we go through this module, we're going to take a look at what is a container. And so we're going to take a look at a thing called a CI, or container instance. We're going to take a look at a feature called a container app. We're going to take a look at a container in an app service plan. And then we're going to take a look at a full AKS solution, or Azure Kubernetes solution. Now, officially, the course is only going to cover these two. I'm going to introduce the other ones just so you can see the full range. Now, in the general description, a container instance is just that. It is a standalone container all by itself with no orchestration. A container app provides for a grouping of containers that have light orchestration. A container inside of an app service plan is a single container that is getting its orchestration from the app service plan. And so if you've seen that module where we covered what an app service plan is, the orchestration of scaling, the resource allocation, all of that comes from the app service plan. And in an AKS solution, you're using a full Kubernetes solution to manage a number of different containers, all managed through an AKS solution. So taking a look at what a container is, we have the environments to be able to rapidly deploy, especially microservices, these container-based applications into an environment based around either a pre-built set of container registry images that you've either configured or going to some container registry that you've actually downloaded images from, or you can download them directly from that image location. So this is where we're going to take a look at hosting those environments, and an Azure Container Registry allows you to build that space. And it's a storage location, very much like a storage account, that's going to have the standard features that we covered in a storage account. It's going to be regionally based. It's going to have multiple copies for high availability. It's going to store those container images that you could then pull that information down from. Now, there's certain features, and we'll show this in the deployment. You can either have a basic, standard, or premium container registry service, which all indicates the size and the replication of that information, potentially to multiple locations. Because if you're deploying applications from a global perspective, I don't want to have to come back to a North American container registry to deploy images inside of maybe a European or Asian data center environment. But I don't want to have to manage multiple instances. So how we manage this will happen depending on the container registry service that you build, and we'll take a look at those multiple tiers. I've already described some of these for you. So now you have images and artifacts that you're working with. So inside of the container registry, you have images. An image can be a plain vanilla operating system that is going to be based around a Windows or a Linux environment. And then you can then have, just as I said, a plain vanilla container, or you can add tooling that you might want to work with. Now, this becomes a bigger conversation that we're not going to get into here. So there's certain ways that you can take a look at it. So if you have a host environment for your containers, I'm going to go back to my green container that I had. I have a choice to bring a green container from a container registry. I'll just mark it as CR. So I've got this container that I'm going to use a build process to get some code to deploy that. Now, it's going to then carve off some memory address space under the host operating system and give me access to all of the tooling and features of the host operating system. So I have a choice, and this becomes one of those conversations that says, maybe I need to have a version of that green image in my container registry. So I'm going to have another version of the green container. But now I'm going to put some additional tooling in it. So I'm going to write some blue tools so that I can deploy a green container that will carve off its separate memory address space and resource allocation. But now it's a container with some tools. Now that means I have to manage two different containers, one with the tooling and one without the tooling. So if there's a patch that needs to be applied, I'm managing multiple images. What you could do is I could have another green container. Let's do this here. I could choose to put the features it needs at the host operating system. So I'm going to draw in purple. I'm going to put some tooling or some service at the host operating system. And now this green container gets deployed. And now this one has access to, as with the other one, access to the underlying tooling. And so this one green container with blue tools also have access to purple, and one without would now have access to the tooling at the base operating system. So this becomes this judgment of, where do I put it? Do I put the updates and the changes to the container in the container registry? Do I do it to the base images of the host system? And I build different pools to manage. This becomes, as I said, a larger problem or issue that you might want to manage as a developer. Probably not your role. It's probably going to fall under an infrastructure person managing that for you in your environment. I could also, if I wanted to, at the time that I use my build process, as part of saying go to get the code, go get that container, I could add the tool to the building process of that deployment of that container. So now it deploys the container with the tool in the container, but now it's going to take longer to deploy the container because in addition to just deploying the container, it's going to have to install the tool. So all these become some of the decisions that you have to consider about your container registry. I mentioned that a container at the end of the day is just a storage location. So a lot of the same things that we talked about in the recording on storage is going to apply here. We have different tiers that you're working with. That goes back to the container registry location. You're going to get some benefits that come along with this. Like all data, it's going to be encrypted at rest. So as you put containers into your container registry, they are safe and secure because they're encrypted at rest. You can provide some global redundancy, just like you had a GRS or GZRS that took that information that exists in the main primary location and replicated that content to other locations. And so you can do geo-redundancy. You can geo-replicate that information to go to locations, much like in the geo-redundant pairs, which are managed by Microsoft. You might want it in other locations where you can target specific images going to specific locations. Zone redundancy, so that you're not dependent on a single data center within a region. All of those constructs, go take a look at the Azure storage recordings, and you'll see a lot of that similarity, because at the end of the day, this is just a storage account, and as opposed to storing blobs or file shares or tables and queues, it's now storing VM or container images that you're working with. We talked about the build process, and you could then use tasks to go through and provide that quick deployment. And that build process is going to either just deploy the base container, it could take that container and modify its deployments by adding something to the build process, or you could make that choice to build that infrastructure into the base environment for the management of the host environment for the containers that you're working with. And there's all sorts of features of, quick tasks. You have some automated tasks, multi-step tasks, depending on just the level of complexity that you need to add. The deployment file, or the Docker file, is based on that language called YAML. And for me, this is probably one of the most frustrating languages to use. It's not just about writing code and syntax, it's got to do with formatting. And the tab and space indentation of this is very, very specific. And so if you add an extra space, everything from that point on could potentially error out for you. So there's lots of little problems and challenges, especially when you're breaking into this environment for the first time, of learning how to deploy content through these builds processes to get them work properly. And you're just seeing an example of it specifying the parent image that you're going to work with. You're doing some updates to the OS package. They're going to then configure Nginx environment, so doing some customization to that deployment, and then deploy your code inside of it. So just showing you some examples to provide automation for that deployment process. You got working directories, you got your website code to the container that's going to take the repository information. So just taking a look at that process. This is going to get us into an exercise where you get to actually deploy a container registry, populate it with images, and then be able to deploy that container and put content into it. So we'll let you go off and do that lab.
In this lab, I'll build a container image and I'll push it to the Azure Container Registry using Azure CLI. Let's get into it. I'll start by building the container registry. I'm going to create a Dockerfile, and this Dockerfile contains a single line that references the Hello World image hosted in the Microsoft Container Registry. This is going to build the image, and after the image is successfully built, and pushes it to my registry. This command will list the repositories in my registry. This will list the tags on the sample Hello World repository. This is going to run my container image from the container registry. I'm going to minimize Cloud Shell, and I'm going to take a look at the container registry. So inside of my resource group, there's the container registry that we just created. I'll go take a look for the repository. And there's my container. Pretty straightforward lab. Let's return back to the recording.
Welcome back from the lab. We're going to close out the module now with doing our regular knowledge check. So question number 1, which Azure Container Registry option supports geo-replication to manage a single registry across multiple regions? Go ahead and pause about the recording to think about your answer. Welcome back. We take a look at the premium service to provide that geo-replication of that service. Question number 2, which Azure Container Registry tiers benefit from encryption at rest? Go ahead and pause the recording. Like all Azure storage, all data is encrypted at rest. So all storage tiers of basic, standard, and premium support the encrypted at rest. So closing out module number 1, we've started our container journey. We did a larger discussion about what a container is, the different features of what a container is and the environment it lives in. Containers have pods that are managed through the orchestration components, usually through some Kubernetes solution, but there are other ones out there. So we had this broader conversation and we saw where a container registry plays. We saw that we could build our own container registry by going and putting it in Azure, populating it with images that we get from repositories like the Docker Container Registry, or I can deploy them directly from the Docker Container Registry. But if I want to provide some customization of those images or even build my own images, I can now store them in that repository. We saw that using a build process, which is based on a YAML file, that you can now take the code from your code repository, taking an image from your image repository, and configuring the deployment of the code in the container to a managed environment, to a pod, where you can potentially have more than one container in the pod. Most don't. And there it's going to get its resources. You could then scale that to say when that container is at its full capacity, it's used all the resources allocated to it, you could have Kubernetes, in this case, to expand and scale out another build of a container with that same configuration and application. And now you've got 2 sets of that application providing that capability for you. I want to thank you for joining me on this journey, and I look forward to seeing you in the next recording